Okay, in this video we're going to look at several examples of using the definition of the derivative or the four-step process to calculate derivatives of functions. So find f prime of x using the definition of a derivative. F of x is 3x squared plus 2. So our goal is to be able to have all the ingredients we need to define the derivative in terms of the following limit. As h approaches 0 of f of x plus h minus f of x all over h. So step 1 is I'm going to find f of x plus h. Well, f of x is equal to 3x squared plus 2. F of 7 would be 3 times 7 squared plus 2. Whatever's in those brackets is what we plug in for x, what we replace x with. F of x plus h means I'm replacing the x by x plus h, so 3 times x plus h all squared plus 2. We have to FOIL that. When you FOIL, you'll get x squared plus 2xh plus h squared plus the 2. Now I'll multiply all those pieces in the bracket by the 3, and we get 3x squared plus 6xh plus 3h squared plus 2. We can look for like terms to combine, but I don't see any. Okay, step 2, calculate f of x plus h minus f of x. So I'm going to calculate the top of that expression. So that's 3x squared plus 6xh plus 3h squared plus 2 minus f of x minus 3x squared plus 2. Notice that the 3x squared, the minus 3x squared are going to cancel, and the 2 and the minus positive 2 are going to cancel, subtracting both things in that bracket. So I'm left with 6xh plus 3h squared. Step 3, calculate f of x plus h minus f of x all over h. So 6xh plus 3h squared all over h. I'm going to continue that up here. Plug into limit. And evaluate. So we get limit h approaches 0 of 6xh plus 3h squared all over h. If we take the limit right now, we get 0 over 0. So we have to do some factoring. I'm going to factor an h out of the top. Yes, you can also factor a 3 out of the top, but it's not necessary. Just going to factor an h. H times 6x plus 3h all over h. Now I'm going to cancel the h's. That gets rid of my 0 over 0 problem. I'm not breaking any math rules. I'm not dividing by 0 because this is taking a limit as h approaches 0, which is almost plugging in 0 for h, not exactly plugging it in. So I get limit h approaches 0 of 6x plus 3h. So that's going to be 6x plus 3 times 0, which is just 6x. Now, later on, you're going to see that there's a fast way to do this. Really fast, like one line fast. Derivative of 3x squared plus 2 is just 6x, and that's it, you're done. But this is the beginning. This is more closely connected to the meaning of derivatives. So we're going to do a few this way, and then I'll show you all the shortcuts. Okay, next one. F of x is 4 over x. I'm going to go through the same steps. I'm going to find f of x plus h. Well, I don't want to just number the steps. I want to write down the goal. The derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h, where f of x, I'll use a different color actually, f of x equals 4 over x, f of x plus h is equal to 4 over x plus h. By the way, that's not equal to 4 over x plus 4 over h. That's not true. You can do an experiment. Check that if you don't believe me. Next, I'm going to subtract them. So that was step 1. Step 2, f of x plus h minus f of x. That's 4 over x plus h minus 4 over x. We need to make common denominators to subtract. So 4 times x over x plus h times x minus 4 times x plus h over x times x plus h. We have 4x minus 4h. That minus sign hitting both pieces on the right. And we subtract them times x plus h. The 4x and the negative 4x cancel. We get negative 4h over x times x plus h. Now I'm going to plug this in up here and do steps 3 and 4 together. So limit h approaches 0 of negative 4h over x times x plus h all divided by h. So that's going to be limit h approaches 0. I'm dividing a fraction by h. So that's the fraction divide symbol h. Same as multiply by 1 over h, which turns into this, minus 4h over xh times x plus h. I can cancel the h's top and bottom now. Previous to that, it was 0 over 0. And then we can take the limit of what's left. Negative 4 over x times x plus h. So we get negative 4 over x times x plus 0, which is negative 4 over x squared. That's our final answer. X times x is just x squared. There. So what are we doing? We're just using a formula, right? Or previous 2 slides ago, this is the definition of the derivative. This is an operation we're going to do. I get another function out there, I get another function out there, but so what? Like, what does this mean? Just wait. Okay, last one we'll do, last example type, we did a polynomial, we did a rational function, now we're going to do a radical function, a square root. So our goal is f prime of x equals limit h approaches 0 of f of x plus h minus f of x all over h. Step 1, I want f of x plus h. F of x is equal to the square root of 4x plus 9. F of x plus h is equal to the square root of 4 times x plus h plus 9. Which, let's see, I'll simplify. I'll multiply the 4 into that bracket, so we get 4x plus 4h plus 9. Step 2. What is f of x plus h minus f of x? That's going to be the square root of 4x plus 4h plus 9 minus the square root of 4x plus 9. We cannot subtract within the square root signs. It's not allowed. So we can't do anything at that point. Step 3, f of x plus h minus f of x all over h. Not much we can do there either. Square root, just going to copy it. 4x plus 4h plus 9 minus the square root of 4x plus 9 all over h. Now I'm going to continue up above. I'm going to plug that into the limit. So step 4 equals limit h approaches 0 of all that stuff that's there. 4x plus 4h plus 9 minus 4x plus 9, each one in the square root, all over h. Look what happens if you plug in 0 for h. You get root 4x plus 9 minus root 4x plus 9. So 0 on top, and plugging in h equals 0 gives you 0 on the bottom. 0 over 0. What do we do? You can't factor it, but you can do the rationalizing trick. Multiply by 1. So multiply by 1. What form of 1 are we going to use? The same one we used last time. We're going to take the square root, the two square root pieces, copy them, but instead of putting a minus sign in between, we're going to change that to a plus sign in between. And we're going to use that for the top and the bottom. Using the same thing top and bottom, make sure it's a 1. Using that particular form is going to help us move the square roots around and get rid of the 0 over 0 problem. Change that to a plus sign. 4x plus 4h plus 9 plus square root of 4x plus 9. Okay, and now we FOIL the top. Do not FOIL the bottom. Don't expand it out. You'll hide the simplification that happens. Limit h approaches 0. We have root a times root a, which is just a. So 4x plus 4h plus 9. We have minus square root of 4x. Be careful with this red arrow. Four x plus 9 multiplied by, so this is inside times inside, 4x plus 4h plus 9. And then I have plus outside times outside plus square root 4x plus 4h plus 9 times 4x plus 9, so that's square root. And then the last times last, so minus square root 4x plus 9 multiplied by square root 4x plus 9. All divided by h times the square root stuff. Okay, now lots of stuff thankfully cancels. I can cancel this and this. Limit h approaches 0. 4x plus 4h plus 9 minus 4x plus 9, since root a times root a is just a. The bottom doesn't change. And lots of stuff cancels. I get a cancellation of the 4x and the net minus 4x and the 9 and the minus 9. And all I'm left with is a 4h on top. Those h's cancel. I can replace all the h's with 0 after doing that cancellation. We get 4 divided by square root of 4x plus 9 plus another one of the same thing, plus the square root of 4x plus 9. So that's 2 of those things. Something plus itself is 2 of that thing. So 4 divided by 2 times the square root of 4x plus 9, which is 2 divided by the square root of 4x plus 9. That's our answer. Yucky!